Hello everyone, I'm Max and I welcome you to Keep Code Real. Today is Wednesday and there's no better day to pick up that keyboard and continue implementing our stock counselor project version 0.1. Before we code away into the better future, I would like to drop a quick refresher of where we have left our project last Wednesday. We had a successfully implemented boundary logic, which is represented with HTTP server in our case, because HTTP request is how future users will interact with the data gathering service. Let's briefly review lines 85 through 89 of boundary API file. In between these lines, we have mapped a URL, collect stock data, which is how users are going to request our data gathering service to collect stock data about a certain company that is represented with a parameter acronym name. At line 87, we make aware our boundary module about the existence of the controller by initiating the object of type controller, right, of class controller. And at line 88, we send an input from our boundary. We send acronym name, which represents the company that we are interested in collecting data about. And we call the collect financial data, which is part of the controller object. Jumping to the collect financial data method itself, we arrive at our controller underscore API.py file. And maybe you remember, or as you can see from the screen, we do not actually collect the data, because the purpose of data gathering main service is to submit a backend task, which will be picked up in the future by a data gathering worker service. And the worker service will do the heavy job. It will collect the financial data. Now, the controller does not directly interact with the place where we store our backend tasks. Instead, it has a private property, which we have named underscore backend tasks, and the property reveals a couple of methods. For example, at line 43, it reveals a method create task, but we use, actually it's better to say we use, a method create task by company acronym. If we jump to line 66, there's another method that we use, which is named getTask by company acronym. And both of them are part of the private property underscore backend tasks. Now, if we click on it and jump to its initialization, well, not surprisingly, it's actually an object of class backend tasks. Clicking on the class in its turn, we will arrive to yet another file, which is named backend underscore tasks underscore API.py file. And the file contains all the necessary logic for the backend tasks class to fulfill its purpose. As to the purpose itself, we have already documented it. At line 9, we can see that our backend task is expected to CRUD tasks directly through the file system. Now, CRUD is a short version for a couple of words, right? Create, read, update, delete, tasks, and directly through file system, which means that during this version, we will store our tasks as text files. Nothing fancy, however, it's also not an optimal and not a desirable solution. In the future versions, ideally, we will substitute our direct communication with the file system with a tool which was specifically created and to manage the tasks, for example, Redis or RabbitMQ. For now, we will not touch them. First of all, in order to set up the tool, we will have to specify the host, the URL, create a bunch of queues, also probably pull an image to a Docker, create it into a container. It's just a bunch of additional workload for a non-car logic. all we want to do is share a task between main service and worker service. Both of them, for the foreseeable future, will reside at the same PC, at the same local host. So they will have an access to the same, file system, which is for now, it's okay to represent our tasks as simple text files available to the both services. Having the context of what we've done and what we are doing today covered, we are ready to proceed and actually implement the Backend Tasks class. As usual, we will be starting from its dependencies. At line 1, we are importing the load and dump functions from the module JSON. JSON is actually a format, and a couple of more examples will be XML and YAML, and it's worth googling, right? If you're not familiar with it, just read an article. You don't need any tutorials like what it does, when do we use it, and how it looks. Basically, JSON is a key value format of data. In our case, we are talking about tasks, which are represented as dictionary objects in the program that is running. However, when we want to store it, we will need to transfer the dictionary object into a string representation that can be stored, right? The function dump helps us to do that. It can take a dictionary object and turn it into a string representation, which we store in the text files. The load function does the opposite. It picks up a string representation, right, and turns it into a dictionary object. At line number 2, we are importing the path function from the OS module, which stands for the operating system. We will need it to build the paths to the files, to the text files that store the backend tasks. At line number 4, we are importing the loggable class from the common module. We've covered it last week. Basically, any class that extends loggable has a couple of methods to log the details, for example, the execution details. At line number 5, we are importing the backend task progress enum, which contains a couple of constant values for the backend task progress, right? It can be either started or in progress or finished. Having the dependencies covered, let's move on to the declaration of our class. First of all, at line number 7, we are extending the loggable class. Now let's click on it. Okay, this is the declaration of our loggable class that we will implement in a couple of moments. Once extended, it provides access to the methods debug, error, and info. All of them eventually log details. However, they do it at the different detail level. Okay, back to our backend tasks. Cool. Let's move on to the constructor. First of all, our constructor receives a single argument, which is a log ID. We use log ID in order to help our class to identify the right logger that should be sent the execution details. We do that because a loggable class is part of a common module, which means that classes from different services will eventually extend it. Each service will have its own unique logger, and in order for the classes of the services to send the details to the right logger, they have to be able to identify it, and they will do so with the help of the log ID argument. And now as to the body of our constructor. Nothing magical happens here. We are substituting pass with a single line. So first of all, we will call the super constructor, which means that we will call the loggable constructor, which, as you can see from the definition, expects two arguments. First of all, ID, obviously the ID of the logger, and the class name, which will be a simple string. So we send the log ID, and our class name is obviously backend tasks. Done. Moving on to the create task by company acronym method. At line 19, its name is self-documenting. It does precisely what it says, what it stands for. There's a single argument acronym. It is expected to be of type of string, and it is a stock symbol, or in other words, a unique identifier of a company at a stock exchange. We expect our method to do the following. It will, at the beginning, log the entry point, initiate a task object which is going to be of a type of dictionary. After it, it will get the path to the file that physically resides on the PC's memory. It will open the file and write the task object contents to it. Eventually, it will log the finish point. Now, back to step 1. At line 25, we will call the method that we extend from our loggable class, which is debug. It expects to receive the method name create task by company acronym. And the message is start because it is a starting point. Our argument is acronym of type of string, and we concatenate its value. The task object initialization, so we call it new variable task. It is a dictionary. Its first key is acronym, right, for which company we do the job. We will store the acronym value and the progress. We will get help from our enum class backend task progress. Right now it is for sure a started task, and we will need to access the value, otherwise we store the backend task progress started and it isn't pretty, right? Okay, we have our task object. Moving on to the file path that will contain it. Let's create a new variable, backend task path. Okay, and we will in a couple of moments implement a method get backend task path. It is part of our actually you can see it right away at line 66. We'll implement it shortly. Our get backend task path method needs only an acronym, and it will return a path to the file that will contain the task's contents. Once we have the file location, we will open it with open backend task path, and we need the mode write plus. What it says is that we can write to the file, and in case it doesn't exist, the plus gives us the rights to create a new file as write file. Okay, so we have opened our file as a new variable write file, and now we will use the dump function from the JSON module. We will take our task and transfer it into a string that will eventually be written to our write file variable. If everything succeeds and there's no error, we can take care of our last step, which is to log the finish point. Function name is still create task by company acronym, and the message is simple, finish. Since we have helped ourselves with get backend task path method, I think it's about time we actually implement it. So at line 67, there's its definition. First of all, this function has to go away once we have a version 1.0, because once we manage our backend tasks properly, there's zero reason to have any interaction with the file system. We already know what the method is expected to return. It is a path, and we already know what the company acronym stands for. So all we have to do, this is going to be a one command implementation. We are going to return a path, which this is a function that we have imported from the OS module. Point join. We are going to join a couple of strings. So first of all, we go one directory up. Let's take a look at the left side of the screen. Our backend tasks API.py file resides under the data gathering main service, and we would like to store our tasks under the common directory, because main service and worker service will be accessing the backend tasks files. There's a prepared directory which is called backend tasks db, and here we will store our tasks under the directory data gathering. Now let's build our path. So from this point, first of all, we go one directory up in order to get to the stack counselor root directory level, which we're doing with ... Then we want to enter the common directory. Once in there, we need the backend tasks db directory, and our tasks are part of data gathering service, and eventually the file name for our task will be an acronym. Since it uniquely identifies a company, it is sufficient to uniquely identify a task that is aimed at a specific company. And here will go our company acronym, and the type of the text file is JSON, right? It's actually a JSON file, another text file. And let's give the formatter the company acronym. Okay, this is how you properly build a path to the file. The last method that is left to implement is get task by company acronym at line 43. The method is fairly simple. With the help of the acronym argument, it will access the right text file and eventually transfer its contents into a dictionary object that will be returned. As to the steps of the method, first of all, we log the entry point, and eventually we'll log the finish point before returning the result. We initiate the result object, which obviously will be a dictionary. Then we once again get the path to our backend task file. We try to open the file in case it exists, and if it does and we can open it, we read its contents and transfer them into the proper or type, right? The dictionary type. Eventually, after we log the finish point, we will return the result variable. Back to line 50. We will use our debug method, right? So self point debug. In this case, the function name is get task by company acronym. Our message starts with the start, and the argument that we have received is an acronym. And let's pass its value. Nice. Now, as to the result variable, so it starts as an empty dictionary, and we can actually jump to line 65 because there's always going to be a returning our result. So we either return an empty dictionary, which stands for a task has not been found, there is no such task, or our result variable will have the contents of the backend tasks, and obviously it stands for the task has been found. At line 62, we can debug the execution details, our finish point. This is the function name, finish, result, and we will print its contents. Acronym. Oops, spacebar. Cool. So what exactly happens in between the result initialization and the returning of it? Well, we need another variable, backend task path variable, and we will get its value with the help of our getBackendTaskPath method, which expects to receive the company acronym argument. Once we have the file location, we will see if it exists. If path point exists and we send the file location, if it exists, we would like to open it with open backend task path. This time we need only the rights to read it, so we submit the read argument. We open the file as a read file variable, and here happens a little bit of magic. Our result object will receive the contents of the file. How it's gonna do it? After all, result is not a string, it is a dictionary. It is intended to be a dictionary. Well, we will use the load function that we have imported from the JSON module. Load function will receive our read file. It will read the contents of the file and transfer them into a dictionary. Now, it actually seems that we have completed the data gathering main service implementation, at least as a version 0.1, right? We have our boundary logic all documented, implemented. It looks beautiful. We have our controller logic. Controller logic needs the help of our backend tasks class, and we have just implemented it. Next, we are going to the common directory, and it's about time we have, dealt with it. Let's start for a change from the bottom and go up. The last file in the common directory is loggable API. We've already covered it in the video, what it does, so I guess we should go straight for the constructor. A quick reminder, ID is a log ID. It is of type of string, and it helps us to identify the logger that we should send our data to, and class name is the name of the class that has extended the loggable and is trying to log some info right now. Let's take the constructor arguments and turn them into the properties. At line 12, the first property will be self.point_class name, a private property that holds the value of the class. The second private property will be log ID, which will obviously hold the value of the ID. Cool. Moving on to the methods. As you can see, all of the methods start with an underscore, which stand for the private methods. They should not be directly invoked by anything outside of the class, or the classes that extend our loggable. Now, three methods, right? All of them, first of all, receive a function name that is being invoked right now by the class, and the message that we would like to log. Let's jump to line 16 and create another variable which we will call to log. This will be a formatted message, right? How it's gonna look like? First of all, we will write the class that is actually executing something right now, the class name. After it, we will log the function that is being called right now, the level of detail, the bug, and the last thing will be the actual message, the argument that was passed to the method. And now we just need to pass the values. So class name will be taken from the private property underscore class name. Function name will be the value will be taken from the argument, and message the same as the function name. We can copy paste the implementation and put it also at line 19 and line 22. All we have to do is to substitute the debug level. So for the info method, our level of details is info, and for the error is obviously an error. Lastly, let's create a new line 17. We need to get our logger, and we are doing it with the help of its ID. So it's gonna be self.log ID. And since we're talking about debug level, we will use the debug method to log, and we will send the message. Let's copy paste the line, and at line 21 we are implementing for the error method. Hence, we are substituting debug with an error, and for the info method we will substitute the debug with the info. An important thing to note here is that we do not directly manage the logger object. We use the getLogger method. Now let's jump to line 1, which is imported from the login module. So login module is managing our logger objects, and we do not have to initialize it right here because it already exists. And it exists because for the first time when we initialize it in our boundary logic, as you can see, we have a setup logger method that we have called right before actually running our server, right? We've called it at line 71 when we call the method start data gathering main service. So any class that extends the loggable class will be able to use the getLogger method and get an existing instance of the logger object, provided that the log ID has the right value. Let's visit now the next in line file, which is backend task progress. Nothing fancy here, and we've already used it. It's just a couple of constant string values. Well, backend task progress actually extends an enum, which is why this is our enum, that holds a couple of constant values for the task progress. It's generic, right? Our tasks are divided in a couple of types. For example, gathering data, and later in the versions creating a recommendation. Yet all of them share these constant progress values. The last thing that we have to cover is the backend tasks DB directory. Now, we've already used it once when we have implemented our backend tasks class, but just to clarify, there's a metadata point txt. So first of all, you create metadata when you want to describe the purpose of the values or files or directories that are stored, right? Let's double click on it. There's a to-do, and it reminds us that the directory backend tasks DB should be no longer useful in any case during version 1.0 when we will have an organized tool to manage our backend tasks. In other words, we will remove the entire directory. However, right now we will store text files that represent some persistent data. Right under our backend tasks DB, there's a data gathering directory which will obviously hold the backend tasks related to gathering financial data. It as well has a metadata point.txt, which simply contains a reminder to remove this in version 1.0 when the tasks will be managed properly. And now the fun part. We are going to launch right at the end of the video our application, our data gathering main service for the first time. I'm really excited about it. So let's close all the irrelevant tabs. We will be needing only boundary API file, more precise the host, which is gonna be localhost, and the port number. Let's minimize the directories. Cool. And we will be needing our main.py file in order to remind us what's the name of the service when we want to pass it as an argument to the command that starts our stock counselor project. So let's copy paste it and open a terminal. Okay, cool. In order to run our application, we need to call the main.py file, and let's pass the name of the main service. Okay, it is up. Now I'm using Postman application in order to send HTTP requests because, well, in Windows it's really comfortable, right? No other reason. I've already prepared the data gathering main service directory that holds the relevant the relevant HTTP requests. First of all, let's check that our server is actually up and running. We will send a request to the local host. Port number is 8080, precisely as we have specified it in our app.run command. Back to the terminal, back to the Postman, right? And the URL is monitor. If everything goes right, we will invoke the function 81, the function that we have defined at line 81, which is called monitor, and we should see the hello world response message. Let's check it out. I'm sending the request. Voila, there's a hello world response. Now a more complicated example, right? Let's go to the directory company acronyms. It holds examples for a couple of requests for the companies, but let's go with Microsoft. So request Microsoft data. As you can see, it's still localhost, the same port number, but the URL is a little bit different. We're going for the collect stock data URL, and the company acronym is MSFT. In case you're wondering, for example, Cisco company is represented by the acronym CSCO. Okay, back to the Microsoft request. If everything goes right and our request arrives properly to the server, we will invoke method defined at line 86, which is collect stock data. It will receive the acronym name as an argument, will pass it to the controller, and controller, with the help of backend tasks, will create a new backend task. Let's see that it is actually what's happening. Send. And there's an error. I gotta admit, writing them applications that actually work may be an intriguing experience. So let's go over to our terminal, CLI, and see what's the problem. As you can see, it tells us that there's no such file or directory at common backend tasks db data gathering msft.json. Well, msft.json file should not exist because we are yet to create a backend task. But the directory data gathering should be there. And the problem is probably with the path. As you can see, it starts with 2 dots, which is not right. It should have the complete path, like C, and so on and so on. So let's jump over to line 37, where we try to open the file. And we have the plus, which means that if the file doesn't exist, we should create it. Let's check how we build our backend task path. Okay, here's an error. Our file actually resides in the path point.dir name, which gives us the exact location of point.dir name file. Okay, this will build us the right path, and the reason for it is simple. Path point.dir name will give us the exactly, the precise location of the __ file __, which in our case is backend tasks API file, and it will reside in the data gathering main service directory. We will use 2 dots to go up, and then how we build the path to the file. So let us stop the server, clean the CLI, and fire it up once more. We go back to the postman and send our HTTP request. Voila! The response is financial data collection has been started, which means that we should have created backend task file. Let's jump to our IDE, minimize the CLI. We go to backend tasks DB directory, data gathering, and there's our file, msft.json. Let's see what it holds. As you can see, it holds the acronym MSFT and progress. Task has been initiated. Perfect. Now, let's see that our main service knows to differentiate between situations where there is no file and it should create a new task and tell the user that it has created a new task, which is the case that we have seen right now. And let's try to send another request to collect data for the same company, and this time we expect to see in the response that the task is being worked on. Send the request. Voila, financial data collection is in progress. Now, before we wrap up the video, let's check that our logger does the job. Back to the IDE file, and as you can see, there is let's close all the other files. Cool. There's a new file, point log, which is named data gathering main service point log. Obviously, it represents the execution details that have been logged during our requests. And if we go to its contents, you can see that first of all we have sent a request to the monitor, and its response was 200 OK. And then we have sent a request to collect financial data for our MSFT company. Okay, it looks smooth. We have all the details. We have the debug detail level. We can see the functions that are being called and that are being finished, and the classes that do the work. All right. We have finished our Stack Counselor version 0.1. Thank you very much for joining me. I hope it was fun for you as much as it has been fun for me and Gabro, who is behind most of the code. Next week, next Wednesday, we will start working on version 0.2, which will feature another service, data gathering worker service, and it will explain more how our backend tasks, whole idea works. So I hope everyone will have a great week, productive week, and we will meet again next Wednesday.